This is SHARMA solution class 12 chapter 15 mean value theorems MCQ. We are taking multiple choice questions. Now we have a polynomial equation. So this is an here. Now this equation and there is another equation also. So the first equation has two different real roots, alpha and beta. So these are two equations which I have pointed out, and the first equation, as I just indicated, has alpha and beta as the roots. Root means when you put alpha in place of x, it will be, the equation will give you 0, and same with the beta. So let me write this equation first. I'm just writing two terms. You'll understand why. So a n x to the power n plus a n minus 1 x to the power n minus 1 and other terms equals 0. This is our first equation. And then we are taking the second equation. But let us differentiate it. I'm just differentiating the first equation. It is n x to the power n minus 1 a n plus, and this a n is the, this is not a into n, it is the subscript, right? Then we have n minus 1, a n minus 1 x to the power n minus 2, all these other terms as well. Now what do you see here? This is the first term of this equation, and this second term is actually the differentiation of the second term of the first equation. So the second equation is nothing but the differentiation of the first equation. I hope you got the idea. So basically, if fx is the first equation, the second equation is f dash x. And the first equation, it is already given in the question, is a polynomial equation. Polynomial equation means it is continuous also, and this is going to be differentiable also, and the alpha and beta can be taken as the domain endpoint. So in the Rolle's theorem, what do we know? We need continuity, we need differentiability, and after that, after you perform these activities and finally judge that okay, continuity and differentiability is okay. And as I said, that when we put f dash x equals to 0, fx, that is f alpha, f beta are going to be 0 because alpha and beta are the roots. But when we put f dash x equals to 0, that x is c. In the question, they are already asking that how many root this has, the second equation. And we know in Rolle's theorem that when we have a domain alpha and beta, and when f dash x is equal to 0, whatever value x that gives the equation as 0, that x is the value which lie between alpha, a and b, here in the case alpha and beta. So f alpha is equal to f beta. Continuity is established, differentiability has been established, and f alpha equals to f beta is also established. So there has to be at least one root, alright? There has to be at least one root between these two, because f dash x also we have found out, and it is equal to 0. So what I just explained is written here, and this is how you're going to write. If 4a plus 2b plus c is equal to 0, then the equation 3ax square plus 2bx plus c equals 0 has at least one real root lying in the interval. So the same scenario is seen here, but we have to understand that this equation, from where it has come. This will come later. 4a plus 2b plus c equals 0, that will come later. But this 3ax square plus 2bx plus c has come from where? Now you take 1ax cube, one term. What do you get after differentiation? 3ax square. Similarly, 2bx might have come from bx square. So when you differentiate bx square, you will get 2bx. Then cx. When you differentiate cx, you will get c. And then you can have some d, some constant, because it is going to get 0 when we differentiate it. So if you assume the original equation as ax cube plus bx square plus cx plus d, f dash x is 3ax square plus 2bx plus c, that is going to come. And this we have established right now. Alright, I hope you got the idea. This equation is not given. We have found out that equation from where it has come. Now, this is d, this is d. So we have this f0 and f2. When you put the x as 0, as x as 2, in both the cases, if you see, f0 is already 0 when you put x as 0. Then you have 2. When you put x as 2, what are you going to get? Some terms here plus d. So I'm not writing d right now, but 8a plus 4b plus 2c. If you take constant, that is 2, you get 4a plus 2b plus c. And in this question, it is already given that 4a plus 2b plus c is 0. So 2 into 0 is 0, but still d is remaining. So what do we get? f0 and f2, they both are equal. Okay, I am saying 0 and 2, we have one of the option as 0 and 2. So you can put f0, f1, f2, f0, f2, and after putting all these, I have finally found out that f0 is equal to f2, because they both are giving you a similar value, which is d here. I hope you got the idea. So this 4a plus 2b plus c we have utilized here. So both the time you get f0 and f2 as d. Now this f0 is equal to f2 because both are D. So if you take the 0 and 2 interval, you get continuity, differentiability and FA equal to FB. So there is at least one value, at least one root for this equation, which is f dash x. 3ax square plus 2bx plus c is f dash x. So when you put this as 0, there should be at least one value which has to be between 0 and 2, because between 0 and 2 or the domain 0 and 2 is only satisfying our continuity, differentiability and FA equal to FB. If you put F0 and F1 and F2, you will see that there F1 it is you won't get this equation as 0 or any value which is equal to either F0 or F2. So we have started with the backward say from the back, and then we went go ahead and found out the actual scenario. So this all what I have explained is I'm trying to show it to you. So this D actually is this. D is a term which we have invented here, or you can say we have ourselves placed here. There is no D in the question. You have to add it. This is done just because to show that f0 is equal to f2. For the function fx equals to x plus 1 by x, 1 and 3. The value of c for the Lagrange's mean value theorem. Now in Lagrange's mean value theorem, continuity differentiability is a must. So if we have a function fx, and this is x plus 1 by x, we can use this x plus 1 by x as it is, or you can solve it like x square plus 1 by x like this. So this is clear cut value which is belonging to 1 and 3. This is already given in the question. We have to do nothing with that. Now this 1 and 3 continuity and differentiability, because see, x square plus 1 in the numerator is polynomial, x in the denominator is polynomial. So continuity and differentiability has been established. Now f dash x, you can call it as c also, because question is saying c, so we have just written c. It has to be equal to fb minus fa by b minus a, and this fb minus fa by b minus a is an indication of Lagrange's mean value theorem, continuity differentiability established. Now this a and b, we are going to use a as 1 and b as 3. So in the denominator you get 3 minus 1, which is going to be 2. FB minus FA, that is F3 minus F1. So what do you get? 3 square plus 1, 10 by 3. What is F1? 1 plus 1 by 1, that is going to be 2. So this is not 1, I've just written as 1, but it is 2 actually. So I'm going to just change it in a short while. But before that, a proper discussion has to be understood that in this question it is only asking about the Lagrange's mean value theorem. We are not talking about Rolle's here. So first we have to see that x plus 1 by x is our polynomial, alright? And this polynomial is always, most of the time, is continuous and differentiable in the interval being provided. So when we find out fa and fb, then f dash x or f dash c has to be equal to fb minus fa by b minus a. So this fb minus fa by b minus a, we get a value, then we'll differentiate it. We haven't differentiated x plus 1 by x. So this 10 minus 3 by minus 2 is 10 minus 6 by, this is 4 by 3, and you already have a 3, this 2 in the denominator, and 2 is already there. So 2 you can have in the denominator, 2 2s are 4, so it is going to be 2 by 3 actually. Now this 2 by 3 is simply f dash x, but we haven't found out f dash x. We have just computed fb minus fa by b minus a. So what is the differentiation f dash x? So this is x plus 1 by x. X differentiation is 1. Differentiation of 1 by x is minus 1 by x square. And this 1 plus 1 by x square minus 1 by x square, and I'm equating it with 2 by 3. So this is 3x square minus 3 is equal to 2x square. So when you take this here, x square is going to be 3. X you will get as plus minus root 3. Now what do you see here is this root 3. Negative will cannot come because you are talking about 1 and 3, that the interval or the domain is 1 and 3. So you are going to take only the positive value, which is root 3 here. So I'll just show you how we have stepwise done this. This is how we have done. If from Lagrange's mean value theorem we have f dash x1. So only thing here you have to understand is we are talking about x and c up till now. But in this question it is specifically given that it is x1. Alright. So fb minus fa by b minus a is equal to f dash x1. x1 we are talking about as x and c. So LMV is saying what? Lagrange mean value theorem, or LMV, says that the function has to be continuous differentiable. If it is continuous differentiable, the f dash x or f dash c or f dash x1 in this case is equal to fb minus fa by b minus a. When you have this, so this f dash c, this is x1. F dash x1, fb minus fa by b minus a. So x1 is between what? x1 has to be between a and b. That's what LMV is. That when you have this one, f dash c or x or x1 is equal to fb minus fa by b minus a, this f dash c or x1 has to be between a and b. It has to lie between a and b. So this x1 has to be between a and b. A and b not inclusive. Please remember, a and b is not inclusive in LMV, but in Rolle's it is included. So I will just show you how we have gone about it. How are you going to perform it? And this is a very simple explanation. Rolle's theorem is applicable in case of phi x. Don't worry about phi x. It's psi x, phi s, or whatever symbol they give. It's just fx. And this is equal to a raised sin x, where a is greater than 0. It is given a greater than a. There is a slight misprint here. You have to consider it as a greater than 0. Now we have to be very careful about Rolle's theorem, what it says, and LMV, what they say. So this phi x or fx is a raised sin x, and a is greater than 0. So this a is greater than 0, phi x. So we see here fx, f dash x we are going to find out. Let us differentiate it. So a to the power sin x. A to the power x differentiation is a to the power x log a. Base is e. So a to the power sin x log base e a, and that the differentiation of sin x has to be done. It is going to be cos x. Now this Rolle theorem says f dash x has to be equal to 0. When this f dash x has to be 0, that is the right hand side which we just differentiated has to be equal to 0. So a raised sin x, cos x and log a has to be equal to 0. But a is a constant which is greater than 0. Please remember, in the question itself it is being provided that a is greater than 0. So log a cannot be 0. It's a constant. There will be some value coming. A raised sin x, any constant value has power sin x. Sin x will always give you value between negative 1 and 1. So it cannot be 0. So the only possibility of all these terms being 0 is cos x has to be 0. And when cos x is equal to 0, at what value cos of cos, it gives you 0. It gives you at pi by 2. That is 90 degree. So this pi by 2 is lying between 0 and pi. This is lying between 0 and pi. So this is pi by 2 which is belonging to 0 and pi. Please remember, in Rolle theorem we don't take 0 or pi by 2 because pi by 2 is already found out. So it has to be between some range where pi by 2 is somewhere in between. So this is pi by 2 is the answer. I'll show you how it has to be done. Formally I'll show you. So this is how you have to go about it. You have to solve it. I hope you all have a fair idea now. This question will be taken in the next discussion. Till then, thank you so much and take care of yourself.